Today we are going to look about into data center operation. Okay, so a data center mainly comprises of servers, storage, and network components. Okay, so these are the topics which we are going to cover. In the case of networks, we will be covering OSI layer, TCP/IP layer. How is the addressing format? What do you mean by subnet? How you should define a gateway, and what are the various types of network classes we have. We will be looking into VLAN, how forwarding and routing works in a switch and routers, etc. And with respect to the storage concepts, we will be looking into RAID levels, SAN, and NAS box. If you have any issues and if you're not able to follow, just ping me, or you can just unmute yourself and ask your questions. Okay. So first we will look into what is a network. So a network mainly consists of hosts, routers, and the communication channel. Actually, I don't want to read this presentation, just I will explain what all the things that you have to know in the case of a network. So host is a machine or any desktop or any IP enabled devices. IP enabled means where you can assign the IP address to a system. So those systems can be connected and you can share the data from that system to another system. So which we call as host. Okay? And the routers are the persons. You have different types of networks here. Okay. So how we call this, maybe as a badge, you are a government official's badge or a trainers of the trainers badge is there. Like we have sections, A section, B section, C section. So in the similar fashion, we have different types of networks that we will be seeing it shortly. Okay. So how to communicate between one network to another network also we will be discussing, because in the normal case, you will not be able to communicate from one network to another network without the help of a router. So using router enables you to communicate from one network to another network. And when you are communicating, when you are sharing a data, it is shared in terms of packets. A packet is nothing but an information, or we call it as a payload, or the actual data along with some header information will be there. What does the header information? It is like similar to your postcard. You have the content in that. Along with the content, you have the address stating the pin codes, the name of the person, where it has. So these kinds of information, maybe we call it as a header or the metadata, which is used to take your payload, maybe the content of your letter, to the other end, maybe the destination. Okay. And protocol, we have many protocols. In the case of network, commonly used protocol is IP protocol, TCP IP protocol, and if you want to be sure, the application level protocol are HTTP and HTTPS. These two terms I hope you might have heard. HTTP is Hypertext Transfer Protocol, and Hypertext Transfer Protocol secure with security. Okay, so what does a protocol mean? A protocol is a set of rules or some procedures or some processes which needs to be followed in order to achieve something. For an example, suppose you wanted to communicate between two devices, they have to agree upon certain communication protocol. Then only they will be able to know which is the header part and which is the data part. Header part, where the header part comes, whether the header part comes first or last in the middle. So these are some rules or the procedures which has been laid down before itself, so that the two systems or the host can communicate effectively. So we have many protocol families. In the case of network, the popular one is TCP IP, and the other protocol which we will be looking into is OSI, okay, Open Systems Interconnect Protocol. And in the case of TCP IP, normally, as I said, what all the things that has to be addressed in the protocol is how the data should be formatted, whether it should have spaces in between or whether it is comma separated or something like that. How it has to be addressed. Addressed means how the destination address will be, or how the source address will be, and what port it will be getting communicated. and how it is going to be transmitted. Either it is going to be transmitted Wi-Fi, or it is wired, or it is through optical. There are different standards, communication mediums through which the data can be transmitted. So routing, as I said, routing is nothing but when you wanted to communicate from one network to another network, you need a router which does the routing. Okay, that we will look into shortly. How is the received data? Okay, received data, how it is going to be, the format is something that if there is any headers in between during your transmission, there will be many headers. Okay, just like your post where what you're trying to send it to the destination, it is put it in a postal bag, so it is like acting as a wrapper around your letter. So those things has to be removed at the destination. Only the letter which you have sent has to be delivered to your person whom you have addressed. In the similar fashion, the data will be covered up by lot of wrappers or headers. So those things will be removed and the actual data or the payload will be delivered to the destination. Okay. So normally TCP IP has 5 layers. Okay, 5 layers. Each layer is like a black box which does some functionality. It is like a black box. It seems it will have an input as well as an output. So it takes some type of information and it delivers some type of information for the next layer to process. So what are the 5 layers? First layer is application layer. From the top, from the client perspective, we are talking about, one is the application layer, transport layer, then we have an internet layer, then the link layer, which we call as a data link layer also. The same way, the internet layer can also be called as network layer. And the last layer is a physical layer, which carries your physical data. That is, it transmits the actual data from one end to the other end. Okay, so these are the 5 layers which we are talking about. One is application layer, transport layer, internet layer, link layer, and the physical one. Okay, so in the case of, why I am saying it is as a black box, in the case of physical layer, the data link layer is not worried about how the data is going to get delivered at the other end, whether it is going to do it in a Wi-Fi or wired using copper, or whether it is going to use a fiber. It doesn't matter for the data link layer. Whatever the data that has been sent has to be delivered to the other end using any other mechanism, that is optical, copper, or Wi-Fi. The same thing goes for the data link layer. The data link layer takes care of that, making some addition of MAC address, and we have a preamble. Okay, in the case of data link layer, we have a preamble to start the transmission, and it has also has a what we call as a protocol, Ethernet family protocol, 802 family protocol it obeys. Okay, so it transmits the data from one end means one system to the other system. Okay, mainly it takes care of error correction. Okay, mainly it takes care of error correction, and the maximum, in the case of maximum data that can be transmitted is 1500 bytes in the case of Ethernet protocol. The similar fashion, internet protocol takes care of routing from one network to another network. The packet can be sent from one network to another network, or one subnet. Both are synonymous. Subnet or the network to another network using layer 3 IP address. Here it uses the IP address. Here only you will be able to say what is your system's IP address. That we will be shortly knowing it. Okay, so we have IPv4 address and IPv6 address, but we will be looking into IPv4 address for now. And in the case of transport layer, it is taking care using port numbers. Okay, so the port numbers are being used to identify the packets, and application layer is your browser or your mail client or whatever it is. It is the actual application to which the packet is getting delivered. To put it simple, for an example, I'll just go through a short example. Okay, suppose you have a classroom. Whatever the lecture is being taught, the lecture is being heard by all the persons available in that classroom. Okay, but that conversation or the lecture cannot be heard in the next classroom. So here what we called as, it is like a data link layer. In the case of data link layer, whatever happens in that classroom or in that network will be heard by every person available in that classroom, but it cannot be overheard by the other classroom. Okay. Suppose you want your information to go to the next classroom also. So what you can do is you will be putting a PA system, or there will be some connectivity that will be shared between these two classrooms. So that connectivity is being established by the internet layer using an IP address, which we call as gateway IP address. So when you want to move from one network, that is from one classroom to another classroom, you make use of IP address. When you are within a classroom, whatever you are communicating with others, you need not have an IP address, but for that you need a MAC address, which we call as medium access control address. That is called as a layer 2 address, which will be used for communicating with the directly connected devices. Okay. Now, so your packet from one classroom to another classroom is being taken by the internet layer, but whom it has to be addressed? There should be a person inside. Suppose you have a couple of systems or something, a few number of systems in the classroom, to which system this packet or this information has to be delivered is given by the transport layer. So suppose you think you have opened too many tabs, that is one for Yahoo, one for Google, or one for whatever it may be, your webmail or something like that. Suppose everybody is requesting for some information from the internet, but when the packet arrives to your system, it is taken care by the internet layer, but to which tab or to which application it has to be delivered is provided by the transport layer. How it is going to be provided? Whenever you are going to open one tab or one application, suppose you wanted information from a gmail.com, it will have some port number. Okay, based on that port number, your written information, that is your response, will have the port number which has been requesting this information. So to that port number, your packets will be delivered by your operating system. Okay, I hope this is clear. This is the main picture or the architecture of the TCP IP. Okay, now moving about to the internet protocol. The protocol which is being used in the internet layer. Here we have saw the internet layer. So it is making use of one protocol which we call it as IP protocol, that is internet protocol. There it is actually a datagram. A datagram is nothing but it is like a postal. As I said, it is like a postcard. It is not a registered post. It is like a postcard similar. A datagram is similar to your postcard service where you are writing a letter and dropping it in the post box. Okay. Now the letter, the reachability, that is whether the letter has got delivered in the destination, depends upon various factors. It can be lost, or it can be dropped, or it can be stolen by somebody on the way or something like that. In a similar fashion, our IP protocol also works. But there is one guarantee which we call it as best effort delivery. Best effort delivery means it tries to overcome, this protocol tries to overcome all the problems and it makes the best effort to deliver the packet. But even though in some circumstance, due to the router congestion or the traffic in between gets congested, or your packet gets, maybe here we are considering it as a packet. So if it is getting dropped, the sender has to resend the packet and he doesn't know whether his packet is lost or something. So the destination, he may request that my information is not available, can you resend? So that kind of service is being taken care by IP protocol that we call it as a datagram service. And each packet, as I said, it will have a IP address. So it will have a source IP address. Source IP address means from where it got generated, and the destination IP address to where it has to reach. Okay. On its way, suppose the packet gets dropped by a router. Maybe the router may be full of congestion or it is fully overloaded. It wants to drop some packet to have a space for it to process. So when it is dropping, some routers may inform the source using the source IP address that I have dropped your packet. I am not able to reach the destination, but I have dropped it due to some problem. So you need to resend. This can also happen. So we are talking about IPv4 address. Okay. but IPv4 is already saturated, meaning that IPv4 is fully utilized and we are going to migrate. We are going to migrate. No, the process of migration has already been taken place for IPv6. Okay, so we will discuss about IPv6 a little if you have a time. Now, concentrating on IPv4, okay, it consists of 32 bits. Actually, 32 bit is something, it is divided into 4 equal parts, that is 8 bit each. Okay, so each field can have up to 255, that is a maximum value, that is 0 to 255 values it can have. So how the IP address will look is something like, in the bottom you can see it is like 1.0.0.0 or something like that. So now when we are going to have the IP address, mostly even if you are getting your mobile data connected, you will be having IPv4 address. Nowadays you can have two addresses. One is IPv4 as well as IPv6 address when you are connecting to your mobile data. Okay, there will be two addresses which you can look into using about, where in the settings you will be having about and you will be having some status. In that status you can see the IP address will be there. If you are disconnecting, that field will be empty, and if you are getting connected, there will be some IP address being assigned to your mobile device. Using this IP address only, you will be able to communicate with the external world. Okay, it is like a IPv address is used to give you some identity. So this is the person which is going to request the information to the world, and the response also will be getting delivered to you. If you don't have an IP address, the response won't get delivered to you. So the IP address is mainly used to tell your identity to the external world. Okay, so we will be covering a detailed one on this diagram. Okay, there are many, there is 5 types of addresses. One is class A, class B, class C, class D, and class E. Okay, so which we will be discussing shortly. Actually, there is some other slides which is elaborately going to discuss about this class A, B, C, and D, and E. Okay, so normally you have a local area network, which we call it as a LAN network. LAN network is something called as a local area network, where you have, suppose you take care of your lab or training lab or your office area, workspace. All the systems will be connected to a switch, and you will be having some servers also connected to the same switch or in a different switch. So what happens is, whenever you have some internet connectivity, whenever you want to access the internet connectivity, either your router or a firewall will allow you to directly access the internet, or through some proxy servers you will be able to access the internet. So there are a lot of configurations in that, but the local area network which we are very specific is, it is actually within a campus or within a room, which is where the computers are getting connected. Okay, so here, as you can see, the bottom part is all the host, that is the systems which are getting connected. And you can see the PDA, that is personal digital assistants, that is being connected to the Wi-Fi access points. And in the same way, laptop also using the Wi-Fi, it is getting connected. Okay, and you can see the IP addresses. It is 192.168. It is maybe 0.11 to 0.49 or something like that. And in the similar fashion, every system has some IP address. So it is connected to the, all the wired is connected to a switch, and the switch in turn is connected to the router, which is taking your traffic to the outside world. Okay, maybe here you can see there is a management console and one more peripheral router is there. Okay, from there you can reach the internet. So this is about the TCP and UDP. As I was telling you, TCP is like a registered post with an acknowledgement due. Whatever you are trying to send the packet, okay, it reaches the destination, and the destination has to send an acknowledgement stating that it has received the packet and it is waiting for the future packets. It is like a registered post with an acknowledgement due. But in the case of UDP, it is like a postcard which you have to drop it in a post box. The delivery of that is not guaranteed. Okay, the receiver, if he is able to tell the source that he has not received whatever packet he has to send, or he has not received, so he can retransmit. So that kind of payload, which we call it as UDP. Why these two things are there? Both are being used popularly in our world. Okay. So in the case of UDP, there is no acknowledgement. Whatever packet you are sending, there won't be any acknowledgement from the receiver. And there is no information about the retransmission. Suppose the sender doesn't know whether the packet has got lost in between, so it needs to initiate a retransmission. It is not aware of that also. And suppose you are trying to send 1,000 packets, all the 1,000 packet may not arrive in the same order in which it was transmitted. So that is also a problem in the case of UDP. Suppose you are sending a file using UDP. If the packet is are not arriving in an order, the file will get corrupted. So all the content will be like a garbage. Okay. So mainly UDP will not be able to use for your file transmission. If you're going to use it for the file transmission, then the application should make sure that the order or the arrangement is in proper, then only it can be used. Okay. As of UDP, it cannot do this work for you. Okay. And one more main concept is it is connectionless. What we mean by connectionless is before initiating a packet, there needs to be some connection establishment, what we call as handshaking. In the case of TCP handshaking, there is some process that is between the server and the client. They will negotiate some parameters. What are the parameters? How much for speed you will be sending the data and how much memory I should allocate as a buffer to hold that one before processing or sending it to an application. So these kinds of informations are being shared that we call as a handshaking. In the case of TCP, we have in the initial also, that is before transmitting the actual data also, we have some handshaking, that is negotiation taking place. And in the same case, when you have sent, the sender has sent all the data, it cannot abruptly cut the connection. It has to make sure all the packet has been received at the other end. So we will call it as a disconnection, or the termination handshaking is also taking place in the case of TCP. But those things doesn't happen in the case of UDP. Suppose the sender has some data, he just like that throws the data. He doesn't even know whether the client or the destination is live or active. He just throws the data. Okay. So TCP is connection oriented, whereas in the case of UDP, it is connectionless. As I told you, flow control is there because as there is a negotiation that is happening between a sender and the receiver, saying that how fast it can consume the data. So accordingly, only the sender can pump the data as well as the receiver will receive the data. So these are some of the applications which are using the TCP protocol and UDP protocol. In our day-to-day life, main purpose of UDP is being used for DNS. Without DNS, you cannot access internet. What is the use of DNS is? The DNS helps to convert all your domain name. That is, suppose you're typing gmail.com or yahoo.com or whatever it is, ctech.in or something. It is a name which needs to be converted to the IP address. As I told you, IP address is used to tell your identity. So you are not typing the IP address. In the end, every server, either it may be a google.com or it may be a gmail.com or whatever it may be, at the end, it will be having a IP address. So the DNS is helping to convert the name into your IP address. So mainly it is using UDP protocol. The rest of the protocol mentioned here, FTP, file transfer protocol, HTTP, POP3, mainly used for your mail, telnet protocol, everybody uses TCP protocol. So in the case of TCP protocol, we have connection-oriented protocol. It is a connection-oriented protocol. Why we are going with connection-oriented? It is reliable. Okay, and it is reliable and persistent. Persistent means it can leave for maybe in the case of session break or connection, there is a connection down means it can restore its connection back. Suppose you are sending a huge file, okay, in between it gets cut. You need not transmit it again from the start. There will be some session variables which will enable us to start from where it got corrupted or where it got interpreted. So now we are talking about the Berkeley sockets. These sockets are nothing but these are the application API means application programming interface sockets. These sockets are being used in your programming languages, whatever programming languages you use, Java, Python, where we call it as an API. So these are the sockets through which your data will be sent. So we are sending that, the Thunderbird is sending, that is a web mail is sending the mails to the other end or to your destination. How it is being sent? Using these type of sockets. The application, your web browser, in the back end, it is creating sockets at OS level. Okay, through this socket, your data are being sent to the other end. Okay. So this you can see it in the diagram. The application makes a socket. Okay, through this socket, it sends the data and which is being traveling to TCP/IP layer of that system, and it travels to the another, that is the medium, that is the channel. It travels to the router. In between, you have many, not one. You will be having many routers, and at last it reaches the destination. Okay, the sockets, how the sockets are being identified? Mainly, it is identified using the internet address. Normally, you have internet address means a source IP address and a destination IP address, which uniquely defines. Actually, there will be actually 5 parameters which has to be uniquely defined for a socket creation. One is source IP address, destination IP address. You have the port number, the source port number, and the destination port number. And the fifth one is what type of protocol it is being using. Either it is using TCP or UDP. Okay, if you are using TCP, that socket is called a Steam socket, and if you are using UDP, that socket is called as datagram socket. And normally the system process also uses this type of sockets. Normally, if you have 2 applications which he needs to share the data, or which he wants to copy the data from one application to another application, for example, from Excel to your Word. So it also makes use of internal sockets, okay, which we called as Unix IO. And this is how the socket work. In the case of application, it creates a TCP socket through the TCP/IP port. TCP/IP port is nothing but a buffer or a memory, okay, where the data is being stored temporarily. From that place, it is getting traveled to the TCP protocol. This is the OS layer, which takes care of the data transmission. So the another protocol which we will be discussing is OSI protocol. It is Open System Interconnect Protocol. In the earlier protocol, which we discussed, is TCP/IP, which is the popular one. Okay, but OSI is a standard protocol. Actually, the TCP/IP got derived from OSI. We can say it is derived from OSI. Okay, it has 7 layers. Okay, in a similar fashion, we have application layer, presentation layer, session, transport, network, data link, and physical. But in the case of TCP, we will be having 5 layers. And as you can see, this presentation and session is combined to have an application layer. The functionalities of presentation and session is taken care by the application layer itself in the case of TCP/IP. For that only, these 3 layers are in the similar color, and this segment, that is the transport layer, is in the one color. The network, where we call it as an internet layer in the case of TCP, and this data link layer is called as a link layer, and the physical, we have a physical layer itself. So these are the 7 OSI layers. As I told you, in the TCP itself, each layer has some functionalities which has to be carried out. In the case of physical layer, the media, signals, and the binary transmission, maybe it is a Wi-Fi wired, whether it is using copper or whether it is going to be fiber. So depending upon the medium, it has to have the protocols written for the transmission of the bits. In the case of data link layer, we have MAC address, as I have a MAC address. And there is one more layer which we call it as a logical link control, okay, layer. Within this, there will be 2 layers. Okay, so one we call it as a LLC, and another layer is called as a MAC layer. And the LLC is from where the data independency takes place. After this layer, entire data will be same in the case of all the computers. Okay, in the case of network, normally routing happens. In the case of transport, end to end, as I told you, which application your data has to get delivered. Everything is decided upon the transport layer, where it makes use of port number. In the case of session, when you are trying to visit multiple pages, or when financial transactions, financial websites, when you are reaching, so there has to be a communication between the last page and that is the previous page and the next page. So that and all is taken care by the session layer. In the case of presentation layer, you have lot of encoding and encryption taking place. The application layer, the actual application, whether it is a web browser or it is a mail client. So these are the protocols which are being used in the case of each layer. See, in the case of transport layer, already we have taken a look at TCP and UDP. In the case of network layer, we have already seen IP layer. Other protocols also are available. One is ARP, Address Resolution Protocol, ICMP. Mainly, you might have come across this ICMP, Internet Control Message Protocol. ICMP is being used by ping to check the reachability of a system. So the ping is a command which is being used. And in the case of data link layer, you have Ethernet, which is the popular one which is being used. But you have PPP, that is point-to-point protocol, ATM, asynchronous transfer mode protocol. There are many protocols. Okay, in the physical layer, Ethernet, again, you have a Bluetooth, it is a Wi-Fi, again, Wi-Fi, no, it is a wireless communication. So you have lots of standards at each layer, okay, being used. So this is the actual diagram, okay, very clear. You can be able to see what all the things that is being happening. Suppose a device A wants to send a information to device B. The application layer sends it to presentation, presentation sends it to session, then transport, like this, it goes down, then it goes to the next level, router. See, in the case of router, it can open your packet, but it cannot open your data payload. It can open up to network layer alone, because in the network layer only you will be having the IP address, because the router needs the IP address to know in which direction your packet has to be forwarded or routed. So that is the main case of router. See, here you can see peer-to-peer protocol. Why it is like that means device A and B believe that the packet is being sent. It has not traveled a huge distance. It is from one application to another application. It is like that. The device B thinks that some other application within its system has generated the data and it has come inside. It is not knowing that the data has traveled a huge distance or a huge number of hops. So again, it is in the simpler form with the protocols which we have looked into. So this is what I was telling about class A, B, C, and D and E address. Okay. Normally, you have 4 octets or 4 locations or 4 decimal places. See here, you have 1, okay, 2. Each location, each bit or each octet can have 0 to 255 is a maximum value. Okay. So your IP address, for an example, it can be 192.168.1.1. So each one is having a maximum value of 255. So if your address starts from 0 or if it starts from 1 to 126, so that address is called as class A address. I will tell you what is you mean by network ID and host ID. And if your address starts from 128 or 128, it is called as class B address and it is up to 191. Okay. I think we'll be having a table dissipating these things. In the case of class C, it is 192 to 223. Okay. And in the case of class D, it is 224. Okay. And class E is experimental purpose. It is not being used in your practical. Okay. So what is a network ID? What is a host ID? This is the main information we need. In the case of class A network, you can have up to 255 groups. That is 255 groups means this alone, the blue color octet can take an value from 0 to 255. So if you are saying a class A address means, it seems like you have 255 countries. In each countries, you can have this many systems. This is what emphasize. That is 2 to the power of 8. 2 to the power of 8 here is 256. Okay, you can have 256 big groups. It is like a big unicity. Suppose if you are taking India alone for the example purpose, you can have 256 big unicities or 256 big organization. Within that organization, you can have 2 to the power of 24. That is 8 here, 8 here, 8 here. So 2 to the power of 24. You can have roughly around, if it is like the 16. So you can have 16 million systems here. 16. Okay, it comes into 2 to the power of 24. Wait 1 second. Okay. So network part, as I told you, it is like a classroom. Each network ID is like a one big classroom. In the case of class A, you can have 256 big classrooms. In the case of class B, you can have 2 into 16 classrooms. Okay, and 2 into, as the class C happens, the number of hosts you need to identify, get. For an example, in the class C network, this is the network normally it is being used in our day-to-day life. You will be able to have 2 to the power of 24 groups. That is, you can power of 24 groups, but you can have in each group only 250, or that is 256 systems you can identify. You cannot name more than 256. Okay. So, but this is the normal any organization. Suppose if you are taking many organization, you will be having more than 250. So they will be trying to use class C address. And the class D address is normally used for multicasting. Multicasting is nothing but where you want to of selected group of destination. Suppose you will be sending it to this address, class D address means it will be getting delivered to not one person, it will be getting delivered to a group of persons where we call it as a multicast. Okay, this is the header format. Before that, I will show that slide. 1 second. This is where the network net ID and there. Then this is the table. In the case of class A, 22 to 223. And this is the valid network numbers. As I told you, it can start with 1.0.0, and it can span up to 126.0.0.0. In the similar fashion, you have the network 256, 2 to the power of 8, 256, but the 0 is not being used. So you will be having 126 big networks, and 2 to the power of 14, again, the same, 2 to the power of 21. And the host, the number of host name or identify, as I told you, it is 2 to the power of 24 minus 2. This 2 address is being used. One is for the identifying the network, and one we call it as a broadcast. Okay, broad host. 2 addresses alone cannot be used. One is the network address itself. Okay, and another one is a broadcast address, which cannot be used to name your system. Coming back to the IPv4 address. Okay, this is the header format. Okay, as I told you, it has a meta information, the source IP address, destination IP address. You will be having time to live, how long the packet can be in the world. It is mainly 255. After 255 routers reads this packet, this packet gets dropped or it is discarded automatically. Important information which I wanted to show in this one. In the case of TCP, mainly you have the port numbers. As I told you, the port number is used to tell you to which application the packet has to get delivered. The source port it got delivered, so it got generated, and to which port, destination port tells to which port or the application which needs this packet has to get delivered. There is an acknowledgement. As I told you, TCP has and the sequence number to track the packet. Okay. In the case of UDP number, you have the source port and destination port. You don't have anything sequence number, acknowledgement, or something like that to track or do the retransmission. So again, these are something which you can see in the at the data link layer. You have Ethernet protocol, and at the network layer you have ICMP and IP protocol and ARP protocol, and the fourth TCP. These are the application level protocols. So all this information is there. So from here, we will be looking about the configuration files which will be used for configuring your network or some services which we will talk about. One is, why is the network management is required? So you need to, because you have a set of systems, you have to give a some IP addresses to manage those systems. If it is randomly or ad hoc, then you will not be able to manage your network, and the traffic will be abnormally going out, and you may get hacked also. To manage the network properly in order to the bandwidth choking, or in order to have secured communication to the outside world. Okay. Some of the devices which we will be using /dev. In the case of Linux, it is device. It is universal device. You have a concept called as, in the case of device, you have a major number and a minor number. Okay, that is how the devices are being identified. Okay, access control list. It is like a ACL list. LSPCI command is used to list all your PCI devices, that is peripheral component interconnect devices. LSUSB to list all your USB devices. This is system file system. What is the type of file system that is being used in your Linux? Okay. IP address and what is the speed, mode, MAC address. MAC address, as I told you, it is a data link layer address, and it is normally factory. You can't change, but today world we can spoof the MAC address also. That is, you can keep your own MAC address also. That is possible. And you have what we call as three concepts: unicast, multicast, and broadcast. I'll tell you, when you're trying to send your packet to only one destination, that the receiver of that packet, we call that those kind of packet as unicast transmission. Okay. In the case of multicast, as I told you, it is a group of user, selected group of user. You select some group to that particular, like a WhatsApp group which you create, whatever information you send, it is like a selected group of whoever is available, they will be able to hear you. That is what I told you in the beginning. There are two addresses, IP addresses, that is being left over. One is network address, another one is a broadcast address. So the broadcast address, when you're trying to shout, it will be heard in the entire community. That is, it is like a, suppose you think you are working in TCS, or you are working in some CDAC or something, you have, it is like a Ma all users or something, Pune all users, like that. Whatever you send a mail, it is being addressed to all the users of that center. Suppose you are very particular, then you will be shouting in a particular group. Suppose you are a system administration group, you will be, whatever information you are sharing, it will be shared to that particular group alone. So it is a selected group, which we call it as a multicast. And if you're going to shout for the entire community, it is called as a broadcast. So these are some files where we will be having network interfaces, etc host name, resolve.conf. In the network interfaces only, you will be trying to give the IP address, host name. The host name to IP mapping will be available in the host file. In the host name, your system name will be there. In the resolve.conf, your DNS server information will be there. Okay, this is switching on the mobile data. You are not providing any IP address or any DNS server or informations like that. But this is the protocol, or this is the service which is being used to automatically provide you the IP address, the configuration files, that is which tells you the DNS server where it has to convert the domain name into an IP address. Those things will be taken care by this DHCP service. Okay, and these are some commands which is used to troubleshoot. Ping command is a fundamental and the basic command which is used to test the other end is available or not, whether it is reachable. In the case of, if you are not able to reach, you can use traceroute command, which tells you where the packet is getting dropped in reaching the destination. In the case of resolve error, you are not able to reach your DNS server. You are not unable to convert your name into IP address. Routing error, it is not able to find the destination. And there may be other methods also you can use, like Wireshark or TCP dump. There are other commands which can be used problems. And these are the some commands which is used to install a new network driver. Suppose your system is not able to detect, your OS is not able to detect your network card, mode probe, ls mode, ins mode, and rm mode commands can be used to insert, delete, etc. And these are some files, as I told you, which we have discussed. See here, you can see the IP address is and resolve.conf. As I told you, the name server, that is a DNS server, IP address will be available in this file. Okay, this is the basic command which tells you what is the IP address of that system. Have a look back, and currently you don't have an IP address assigned in this ETH0. So this is the naming convention that is being used. Normally it is ETH0, ETH1. How many number of network cards you have, it will be depending on that. Now, getting back to the storage concepts. In the storage, we will be discussing about two things. One is RAID and another one is the SAN part. So the RAID is very, very important. What do you mean by RAID? It is a redundant array of independent disk. Okay, why it is required? I will tell you. Think you have a server and a hard disk is built into it. Okay, suppose the server gets crashed. Suppose you are running a web server on that server and the server is getting crashed due to the power supply failure. Power supply failure means not the power is not there. The SMPS inside the server, there is one component which we call as SMPS. That power supply alone got failed. So you wanted to rectify, you will not be able to rectify it immediately. Okay, you will not be able to, it will take some time. Here, the data, motherboard, everything is intact, but the power supply is not working. Okay, so your downtime for your website is more. So to avoid those things, what they have done is they are creating a storage pool. All the data is being collected at one storage location, at one location, where the data is being managed by this SAN or NAS, which is using the RAID concept. What is the advantage in using that? These servers are getting connected to this centralized storage, okay, using fiber cable or Ethernet cable. Okay, suppose if anything happens to the server, maybe if it is a motherboard failure or RAM failure or power failure, everything, the data is intact. It is centralized. It is in a centralized pool. The data can be redirected to another server. Okay, within a couple of minutes, your data or your website can be made up and running. So it reduces the downtime. That is the main advantage of this one. So you may ask, using the centralized storage, if the centralized storage gets corrupted or it gets down, what will happen? Whether my data is lost? No, it is not like that. In the case of centralized data, for that purpose only, this RAID concept comes in. Your data is not stored in one particular hard disk. It is distributed across 4 to 5 hard disks. Okay, so what happens even if one hard disk gets failed? Okay, the other hard disk will be able to give the reliable data to the server without any problem of this failure. Okay, some maybe hours or within a day, if you are able to replace the failed hard disk, well and good. It can withstand again. It can withstand. It will come back to the normal. It can withstand again the hard disk failure. So two hard disk failures. Suppose you are storing your data, you can create a configuration in such a way that if two hard disks gets crashed, your data will be intact and it will not have any impact on your server. So by the time you replace these two hard disks, okay, the data will come back again to its restoring point. So how that is being maintained? It is creating a mirror image. It is creating a mirror image on one or two disks. Okay, the mirror image, even if it gets failed, the data is being served from the other disk. So what are the different methods or the levels of RAIDs we will discuss. So this is RAID 0. It doesn't have any mirroring or it doesn't have any redundancy if anything happens. But why it is there, RAID 0? Is being split into 5 MB of 5 MB, 5 MB into two hard disks and it is stored. So your writing time is reduced since you are using two hard disks. So it is enables a faster write time. Okay, so for that purpose, RAID 0 is being used. But here you don't have any redundancy. Even if one hard disk fails, you won't be able to recover the data. In the case of RAID 1, as you can see, there is two replicas. There is two replicas. Two replicas means you have A1 here, A1 also in the other hard disk. If any one hard disk fails, you will be able to get the data from the other hard disk. This is complete mirroring. In the case of RAID 1, it is a complete mirroring. pure storage. Suppose you are having two numbers of 2 TB, okay, the total is 4 TB, but you will be getting only 2 TB, okay, because 2 TB is being used as a redundant or it is a replica. In the case of RAID 3, RAID 4, we won't be using in the production. RAID 3 and RAID 4 makes use of bit level. Bit level means in the case of hard disk, you will be speaking in terms of block or a sector. But in the case of RAID 3, it talks about in bits. Bits means it is talking about in terms of bit and bytes. So that level of splitting of data is not applicable or it is not usable in production. So normally we skip RAID 3 with RAID 5 where block level replication happens. Here, as you can see, A1, A2 are the actual data and AP is a parity of that A1 and A2 is being stored in the disk. Suppose you think any one disk fails, okay, using the parity, suppose this in the middle one, disk 1 gets failed, with the help of A1, you have a data, A2 data can be using the parity, okay, using the parity, so it will be generated. So there won't be any loss of your data due to this disk 1 failure. So this is a RAID 5 which is normally used in production, which can withstand one disk failure. In the case any one disk fails, your data is intact. In the case of RAID 6, the same thing goes, but the parity is 2. So it can withstand, as I told you, it can withstand 2 disks. So as I told you, there is one more RAID 10. In the case of RAID 1, it is mirroring. In the case of RAID 0, the data is getting split. As you can see, A1 is here. In order to get the faster write speed as well as don't want to lose your data, this 10 is used. It is not 10, it is 10. And RAID 0. And whatever I have explained, as I told you, it is block level stripping without any parity or mirroring, and you have no fault tolerance. A loss is a loss here. RAID 1 is a mirroring, complete mirroring. Okay, even if one hard disk fails, you will be able to get the data from the other hard disk. RAID 5, as I told you, it can withstand one disk failure. So these are the some configurations, some drive, some packages which are required. Normal Linux system itself, you can configure the RAID. So some concepts which we will be talking about when you are trying to create a RAID, you will be having logical volume management. This is very, very important. Nowadays, the operating system chooses LVM. What is the use of this LVM is, actually, even bottom, you have many physical hard disks. In the top, you will be seeing only one volume or one logical view. Okay, one logical view. So this, you can see it in the case of picture, which I will try to. Here you have a disk A and disk B. You will be creating a physical volume 1, 2, like a partition. Okay, 1 and 2, and from here disk B. See, you're able to create a volume group with the help of physical volume 1. Okay, that is a partition 1, but a logical volume group 2 is being created from disk A and disk B. But see, the user who is using this volume group, he will not be able to know that whether it is coming from disk A or disk B. He will be able to see it is volume group 2. From here, the volume group 2, you are able to create the logical volume. This is the actual volume, like a C drive or D drive, which you will be able to use in your servers. Here you are creating a logical volume 2, and how it is being created, I will just tell you what are the commands. See, these are the terms which are being used in LVM. One is a physical volume, which is actual partition. Okay, the partitioning of the data. And small parts you will be creating in this physical volume. So suppose you think the disk is 1 TB, disk A is 3 partitions maybe. So each one is called as a physical extent. Okay, so the volume group is made up from the physical extent. Okay, the volume group will be consisting of physical extent. Then from the volume group, you will be creating the logical volume. Okay, the logical volume is the actual one which you will be mounting in your server. Okay, and using it. So what is the advantage of this logical volume? See, on the fly, on the production itself, you will be the volume or decrease the size of the volume. Suppose in this case, suppose your disk A is 1 TB, but your data has grown more than 1 TB. So what you will do, suppose you are trying to buy a 4 TB hard disk, what you will do, you will copy all the 1 TB data to the new 4 TB hard disk. But in the case of LVM, what happens, you need not do like that. You can just increase without any problem, without any actual movement of your data. You will be adding the 4 TB data, and it will be like it is in a pool of, now it is 5 TB of data, and you will be creating volume groups and logical volumes on top of it. Okay, so this is the main advantage. You can shrink dynamically on the runtime your logical volume. You can, suppose you think you have a volume of 100 GB, you can on the fly you can increase it to 200 GB or 500 GB depending upon the demand, or you can reduce it. But this cannot happen if you are having physical disk without any LVM. So these are the commands. Volume create. This is the partition. Okay, and this is, see, this is the different partitions you are trying to create. And the volume group VG create. Normally VG is volume group, PV volume. The same way we will be having logical volume also. You can create, see, VG create volume group name, and it has to be created using the partition SDA1 and SDA2. You can extend, as I told you, you can extend on the fly. You can add 2 more hard disk also on the fly without any disturbance. So this is why how you create a logical volume LV create. You will be creating the number of PEs, or you can specify the size 200 MB or something like that. You can specify, and from which volume group it has to be created. Once it is created, you can change the size. Whatever you do, you can add, you can check. Okay, these are some commands. This is related to volume check, volume group check, and volume group change. And you wanted to convert from LVM1 to LVM2, that also can be done. So these are the logical volume commands. LV change, that is used to change or convert from one format to another format. Display what are the currently available logical, and you can reduce, you can remove, rename, resize. Everything is possible in the case of LVM. See the command used to extend. Here you are trying to extend. Now coming back to SAN storages and NAS storages. SAN is storage area network. As I told you initially, centralized pool of storage which will be in turn connected to the servers. Suppose here what you have, a LAN switch is like a fiber switch. Fiber switch means it is connectivity. All the servers mostly in the case of SAN will be connected using fiber cable to increase from the central pool to the server. In the case of NAS, the same data can be shared using Ethernet cable also. Okay, but the speed will be restricted to the 1 Gbps or 10, depending upon the switch which you are using. Okay, it is the cheapest version of that storage area network. Okay, because it is using Ethernet cable. Because the Ethernet cable by default it will be laid, so you can make use of the existing infrastructure itself to share the storages. But in the case of SAN, optical fiber, you need an optical fiber switch as well as optical cables to get it connected. But you achieve more speed, and you achieve more speed, and the advantage is that you can manage the volumes. You can just like that divert the fiber connectivity from one server to another server using the fiber switch itself. So this is how it is. You will be having servers, you have the storage, and a fiber channel switch is there, that is F switch, and it is being connected to the servers. In the case of NAS, it is similar, but it is making use of Ethernet cables. So this is